Good evening, everyone who has joined this session. Uh, Welcome to the fourth week of problem solving session on industrial wastewater treatment. The instructor of this course is Professor Alok Sinha and Professor S.K. Gupta from IIT Dhanbad. My name is Nitnam Prakash and I am from IIT Kanpur. I am a PhD student. So usually we meet on Tuesday, but due to some circumstances, I won't be available tomorrow. So I have rescheduled it. But from next week, it will be normal from 6 p.m. to 8 p.m. on Tuesday from next week. So that is on from 25th. It will be normal. So you will be getting those mails. We meet online via Google Meet, and the link for which has been already shared with you. Always join using those link, and the recording of this session is also available on YouTube. uh, the link for which has been also been shared with you. Okay, so in this week we have gone through note 2 point that it two topics may I will be saying, that is advanced oxidation process. So if you remember the last session in last week also, that is in week 3, we had discussion about AOP, that is advanced oxidation process with the help of hydroxyl radicals, that is OH dot. So in this lecture, in this week we will be seeing more about this advanced oxidation process. And another way of treatment is membrane process for wastewater treatment. So we will be looking into how these membranes are used to treat wastewater. Okay. So this is the recap of the big three, where we are seeing that AOP is occurring through OH radicals, and there are different method to produce OH. That is, means like we can produce with the help of ozone based OAP, UV visual OAP, Fenton's process, then sulfate radicals. So these are, and this all helps in oxidizing. Okay, because these are very reactive. Then we have electron photon process, where we see, where in photon process we see there is a problem of sludge, but in electron photon this problem of sludge was solved. Then we have ultrasound associated. Then these are uh, different type of radicals. Okay, and if we compare the oxidizing potential, then we know that fluorine is highly uh, fluorine has highest oxidizing potential. Then comes hydroxyl radical, then ozone, then we have hydrogen peroxide. What is the use of this OH radical treatment of organic pollutant in industrial wastewater, enhancement of biodegradability in wastewater before biological treatment, and disinfection? These are some of the process. These are just recap from the last big three. In this was discussing new. This was discussing big four, that is use of UV, that is ultraviolet. Use ultraviolet to inactivate pathogens by damaging DNA. So what happened that there is another this use of UV. So if you have gone through the video lecture, you will be seeing that this type of things has been discussed with you. Where did it go? So you can see that a UV light was passed through the water, and here pathogens are killed. How pathogens are killed? Their DNA are damaged. You can see there is a proper like I don't know the technical terms, but there is some rupture inside the DNA connections, and we kill the pathogens with the help of UV. And here you can see that as these lights, UV lights fall on it, it has some kind of it fall in within that spectrum where m- maximum damage can happen. Okay, so if you are more interested, you must go through the lectures and you will be good to go. Uh, then now efficiency depends upon several things. The first is pH influence. So it is generally said that when pH is greater than 5, then there is a presence of OH minus, OH, and what happened that uh, there is a problem in generation of OH radicals, because already in system you have high OH concentration, so the efficiency decreases. And similarly, when the pH is less than 3, then also due to acidic nature, some problem happen. So best suitable pH is considered to be 3, between 3 and 5. This is also mentioned. Then a scavenger presence, due to presence of carbonate, what happened that instead of formation of OH radicals, you can see that the radicals of see about pH, it is most suitable between 3 to 5. Okay, now what happened that due to presence of carbonate, yeah, bicarbonate, what will happen that this bicarbonate will combine with OH radicals, and it will form again their own. So some kind of efficiency of OH radicals to kill bacteria or to oxidize decreases. Overall presence of carbonate decreases the efficiency, because carbonate, instead of OH radicals, that OH radicals or OH hydroxyl radical, what happened that instead of attacking oxidizing organic matter or any other thing, they started to consume on they started to react with carbonate. Okay, then light absorption, mass transfer limitation is there. This thing we have some of the common OPs are ozone, then H2O2. This thing we have. The best advantage of this here in previous example, like photons example, we have seen that there is a production of sludge, iron sludge, and in many more examples, like adding sulfate or adding any kind of chemicals will somehow produce some kind of a what do we call it, sludge or any chemical problem. But here there is no such effect is there. Effective no residual toxic chemicals is left here, effective against viruses, spores, and it's like we have seen that it damages the DNA. So UV are very effective in against viruses, and also viruses, spores, and cysts. There are some disadvantage also. The first is very costly. The use of UV is very costly. Okay, now some microbes may repair damage. So there are some recent study has found that some of the microbes regenerate on their own in spite of having high amount of UV on them. So it sometimes it's creates some kind of problem. Another method was membrane waste for wastewater treatment, where we use some kind of membrane. So the process is very simple. If you have seen the setup, so this is kind of container. There is a membrane placed here. I'm talking about this. Suppose reverse osmosis is there. So what will happen? That contaminated water will be filled here, and what will happen that a pressure will be applied on contaminated side, and we will get treated water. Okay, now so this is kind of reverse osmosis. Then there are some nano, then we have nanofiltration, then dialysis, different terms of membrane. The overall concept is that we are using some kind of membrane to treat our wastewater. Okay, by pore size. So now imagine that your wastewater contains some kind of particular contaminant which has a particular size. So now imagine that if you are applying a membrane of applying using a membrane of a smaller size, then what will happen that those contaminant will get trapped on those membrane, and you will get contaminated water. Okay, na? So pore size play a crucial role, and depending upon this size, either you will have microfiltration, ultrafiltration, nanofiltration, or reverse osmosis. Then we have by driving force, that is again use of some kind of pressure driven. In reverse osmosis we have pressure driven, then concentration driven, that is known as simple use of semi permeable membrane. We let the pass due to concentration variation. It will automatically, uh, or simply in the common sense, in the normal sense, we also say that due to osmosis, like due to concentration difference, we have osmosis effect na. Then we have electrode even, but we applied some kind of electricity by centrifugation. We like we will see centrifugation is ultra pure water. I have in my lab. I think I have one. I can show you how. See, I hope you are able to see this tube. If you see this tube, there is this thing. Are you able to see it? What will happen that we will pour water here, and it is centrifuge tube. This is known as centrifuge tube. We will pour the water, and then we have centrifugation machine that can go. My lab has facility that can go up to maximum 4000 rpm, but there are some other instrument that can go up to 10k rpm also. Then we will add the water, and then we will be rotating at 4000 rpm. So what will happen that due to force, centrifugation force, all the contaminated will get trapped on this attachment that you are seeing in the middle. I hope you are able to see it, and you will get treated water. So this is known as so generally we are working with some kind of organic acid, humic acid, or say any kind of, and they want to do this kind of generally. I'm giving one example. I might be wrong also. I'm not sure. I know I'm not so much aware. Hmm. But it helps to bifurcate wastewater treatment, bioremediation, food industry, and gas separation. Membrane types are tabular form, hollow fiber, spiral wound, plate frame, and these are some of the things which has me. I think these the from what it's written here, you can imagine what kind of. Then one of the major problem of this membrane is falling. Like what will happen that suppose you are continuously using membrane, so what will happen that some kind of some chemical will be start depositing, some maybe some biological things may also start to attach on it. So there will be kind of fouling. Like fouling is it will like your efficiency will start decreasing. Okay, na organic and inorganic fouling, scaling will be there, biofouling will be there. Then there are central control strategy. Then we have to like control strategy, or you can say maintenance strategy. You have to like instead of we know that membranes are very, very, what do we say, costly. So we will be so we won't be applying directly a huge contaminated wastewater. We will be doing some kind of pre treatment, and then we will be passing it. Then we will be on regular intervals, we will be cleaning it. So no, we know that the contaminant will be attached on the upper portion, so we can do a back washing with the help of some other clean water. And what will happen, that we will have this contaminant removed, and we can again reuse for another purpose. There are something called site density, silt density index. We will be seeing this modified falling index, pre-treatment for NF, pH adjustment should be there, filtration should be there, disinfection should be there, deaeration should be there. So these are some of the common. Okay, now this is last part, membrane bioreactor, that is MBR. Okay, na. So we were seeing simple type of membranes. Okay, na. Now we are especially seeing membrane bioreactor. So integrated biological treatment and filtration, membrane filtration. So here we are in a single unit. We are filtering also, and we are doing biological treatment also. That's why it is known as membrane bioreactor. So there will be some kind of what do we call? What do we call, biofilm type of things. Okay, now so what will happen, that it will biologically treat your water also, and it will remove the, what do we called, it will filter out the contaminant also. High COD removal. We have discussed what is COD, chemical oxygen demand. Okay, na. Compact design is there. Again, like, one of the disadvantage is very costly. It is very costly. Generally, it is used in developed country. In India, still we are in process to make some improvement, so that we can make it in easy way or cheap way. Okay, that's why you in India you might not be heard of this use of membrane bioreactor, but there are some places where there is use of this membrane bioreactor. Okay, na. Disposal of concentrate. These are some of the other techniques. Okay, na. How miss technical, some of the advantage, like right now we have a smart membrane, nanomaterial, data driven optimization. Design problem is there, high energy consumption, membrane replacement cost. So overall it is very costly. Okay, so this was a brief recap of what has been discussed in this big four. Okay, if you have any kind of doubt, you can ask. I know due to, like, sudden change in plan number of students who have joined is very less. Only 2% has joined, but I it's good that only two people. It's also good, we can take it in a positive way, that we can have a proper interaction. So if you have any kind of doubt, you can ask, or we will move to the question and answer. I hope there is no doubt. Let me open the chat box. Hmm. If you have any kind of doubt, you can always write in the chat box. Chat box is always open to everyone. Let everyone message. Hmm. So coming to the first question is very easy question, that is directly from your lecture notes. The optimum wavelength of UV, that is ultraviolet, to effectively inactivate microorganisms is in the range of. This is directly from your PDF. Those who have joined, I request you to please write answer, or is participate in question and answering. Okay, no problem. The correct answer is 250 to 270 nanometer. So ultraviolet is widely used for disinfecting. The correct answer is D. Okay, na. So let's see why. So there is like, see, there is something called a spectrophotometer. So here we analyzed and we see the on which wavelength there is a maximum damage. Okay, na. So that range is defined as optimum wavelength. So will be a scanning. We will putting the sample in a spectroscopy, and what will happen that uh, what will happen that just 1 minute. What will happen that uh, what will happen that we will be scanning between 100 to 500 nanometer, and we'll be seeing that there is a peak at this between this interval. So we will be calling as this as a optimum wavelength. Okay, na. Ultraviolet is widely used for disinfecting water, air, and surface by inactivating microorganisms such as bacteria, viruses, and protozoa. The effectiveness of depends upon its wavelength. The most effective is between 250 to 270, with the peak at 254 nanometers. So what will happen that there will be a scanning, so it will be moving like this. At 250 it will start increasing, then it will be maximum at 254, and then we will be having like this thing up between 274. So between these value there is a peak value. So we will be saying that at this particular in this range there will be killing of microbes. At this wavelength, UVC light damage the DNA of microorganism by forming pyrimidine. These are some of the technical terms. Okay, na. So I'm not going to discussing. So you can see for your reference. I will just say that these things, these pictures where we were seeing, these are like pyrimidines. Okay, na. So and here you can see that there is a peak, and between, oh, it is saying that, oh, okay, so I have one mistake here. It will be 250 264. Okay, na. Not 54, 264, 264. Okay. Ha. So here you can, all these details are there. Okay, so if you want to read more about this thing, I will request you to go to the lectures. So this was a very easy question based on this. That's the optimal lesson is 250 to 270, and the correct answer is D. Question number 2: transfer efficiency of ozone in water. So you have to recall this thing, how ozone reacts with water. And okay, so which of the statements are true? Okay, anyone with any answer? No, okay, no problem. The correct answer is C, that is 2 and 4 are correct. 2 and 4, which are 2, T increases at high pH and low alkalinity, and T increases with decreasing the bubble size. We will looking into this thing. Okay, now the transfer efficiency of ozone refers to the percentage of ozone gas that can dissolve into the water instead of escaping as undissolved gas. Several factors such as influence T, including pH, alkalinity, gas to liquid ratio, and the bubble size. Okay, so this thing we have already know the definition. What is this transfer efficiency? Like how, like if we are passing ozone then to a water, then how much efficiently we are passing the ozone, and it will be called as efficient if the whatever we have passed is mixing. Suppose we are passing 100, suppose we are passing suppose 100%, and only 50% is getting entrapped in water, then we will calling as transfer efficiency as 50%. First option was decrease, TA decreases as water quality decreases. So this is incorrect. Poor water quality. Uh, poor water quality. Suppose we have a water of poor quality having high turbidity, high organic matter, or high dissolved solid, then what will happen that there is a chances of high transfer of ozone gas. Okay na. So this is some kind of mathematically, like you not mathematically you can prove it, but logic you can say that due to high turbidity there is high organic matter, so what will happen that more ozone can is needed to oxidize those the matters, and it will be staying the ozone will try to stay in water. So it is increasing the transfer efficiency, not decreasing. So that's why it is incorrect and not our answer. The T increases at high pH, ozone decompose faster into C. At high ozone, what will happen that if pH is high, then we have too much OH. So what will happen that OH, more OH, then more O3. If you remember the last week reaction, we have seen how ozone, that is O3, react with uh, uh, react with H2O and some other matters also, says H2O2 or OH minus, and it produces OH radical. So if the pH is low, high amount of OH minus is there, so a better reaction will be happening and it will be producing more so yes, transfer efficiency will increase when enhance the oxidation. Low alkalinity reduces the carbonate buffering. Low alkalinity, we have also seen that due to presence of carbonate, what will happen that we have seen example of carbonate. In case of carbonate, the efficiency decreases. Okay na. So what will happen that in if we low the if we have decreased the alkalinity, we have decreased the concentration of carbonate. And alkalinity, we know that it is due to OH minus, H plus carbonate radical and bicarbonate, sorry, not radical, bicarbonate and carbonate ions. Okay na. So this will lowering the alkalinity will also increase the transfer efficiency. So this is also correct. So two is correct. Okay. Decreases as gas liquid ratio decreases. Like higher than reduced TA, but this is not always true. Depends on the system design. So this is like a controversial, like it's not completely true that if we decrease the gas slash liquid ratio, then we have to see other factors. But in a general, if someone asks that if we decrease the gas by, it's like we are adding more liquid than gas, then they can do decrease the transfer efficiency. It depends on several factors. Okay, now.
Sir,
So that's why
excuse
it
me.
is incorrect.
Sir,
Then we have TE decreases with decreasing bubble size. A smaller bubble increases the surface area of the gas liquid interaction, enhancing the ozone dissolution and increasing TE. Okay, now so this is another, this is also correct answer. Okay, that if we are using a smaller bubble, if there is smaller bubble, then surface area will be higher, and that will more surface area, more ozone can be trapped. Okay, or can be dissolved. That's why like the thing is C, that is 2 and 2 are correct. Which of the filtration process listed below can remove bacteria from the water? Okay, explain how I feel.
uh, how high pH will be having low alkalinity? Can you
So
please?
oh, sorry. You were saying something?
Yes, something.
Ah,
High pH is having low alkalinity.
yeah. See, these are two different condition. At the higher pH, it's not necessary that there will be low alkalinity. At higher pH, there are chances that it will be alkalinity will be higher, but it is not. You don't have to consider these both condition occurring simultaneously.
Okay.
Here they are talking about first due to high. See, in discussion also I have not considered both thing. high pH is separate condition, like we are increasing OH plus OH minus concentration, that's all. At that time I'm not talking about alkalinity. And when I'm talking about alkalinity, then I'm not talking about the pH. Okay, na?
Okay.
Just somehow.
Alkalinity means only carbonate. You are considering only carbonate.
No, when we are
Mm.
considering alkalinity, then we have to consider all three things: carbonate, bicarbonate, and OH minus.
OH minus also. Okay.
So somehow we are decreasing the alkalinity. Okay, na? Don't. It's like don't make a condition that pH is also. If you think in that wise, then at higher pH, alkalinity will never be low. At higher pH, alkalinity is also high.
It will be high. Yes. Mm.
You have to consider both options separate. Did I solve your doubt?
No, I'm thinking like that in high pH, the alkalinity also will be high. That's my assumption because OH minus will be more.
But there
So
are high
density
chance.
of pH will increase. So the alkalinity also will increase simultaneously. No? Here it is like in contradictory. High
Yeah,
pH and low alkalinity. Is it possible?
yeah. If you see, now we will be looking at the rate at which we are like decreasing the pH or decreasing the alkalinity. Now imagine that your system, the amount of carbonate and bicarbonate which is present in your system is not so high, is very low, but somehow you are like increase with the help of OH minus, you are increasing your pH. So the amount of alkalinity will also increase, but the amount of alkalinity increase will be not so comparable as in the presence of carbonate and bicarbonate. Presence of carbonate and bicarbonate significantly affect the alkalinity. Okay, now we are just assuming artificial or imaginary situation where the amount of these two are OH, bicarbonate and carbonate are very less. So yes, your doubt are very clear that if we are increasing the pH, alkalinity will also increase. But it's like that we are not seeing. Just a minute. Such a phone. So it's not like that we are how when we are talking about this low alkalinity, we are talking in the mostly in the terms of carbonate and bicarbonate. Okay, so if you look at the
Here, here alkalinity represents only carbonate and bicarbonate
yeah,
and
yeah,
not
yeah, yeah.
OH minus. Okay.
Okay, the complete. If you recall the complete formula of alkalinity, I'm not able to write in proper way, but it is
Okay.
minus H plus concentration
Mm.
plus OH minus concentration. OH minus concentration. Then we have plus bicarbonate concentration. Then we have plus 2 carbonate concentration, twice the carbonate concentration. Okay, so here you can see the we are you know this formula na, alkalinity formula.
I don't know.
Also this is like see, there is experimental way to find out alkalinity, but there is theoretical way that if you know the pH of the system and carbonate concentration, you can just
Okay.
use this formula minus H plus concentration plus OH minus concentration plus
Mm.
bicarbonate concentration and plus
Mm.
twice the carbonate concentration. So you can see that the effectiveness of carbonate is very high as compared to bicarbonate. So overall, if you generalize 3 mole of carbonate is overall carbonate is participating in alkalinity. So
Mm.
when we are talking in this sense, then we are just neglecting the effect of OH minus.
Mm.
Got it?
Okay. Mm.
Okay.
OH minus is there. Okay. Mm.
I hope this is clear. So we will move forward. uh, so this was our question number 3, that which of the filtration process listed below can remove bacteria from the water. So the correct answer is all of above. So see, these bacteria have like we will seeing that filtration process differ in pore size and mechanism, but all these listed filtration methods can remove bacteria from water to some extent. So we will be looking at the size of different filtration. In microfiltration, the pore size, suppose we are using membrane, okay na. Let me show you one, like a simple filter, not micro. I have like, let me show you. So actually, I am sitting in my lab. That's why I am able to show you everything. So generally, so this is. Are you able to see it? Like, I hope you are able to see it. Are you able to see it? This.
Yes, sir.
So this is a like filter. So what happened that it has a membrane filter assembly is there, which has a which has a size of 0.22 nanometer. Sorry, not nanometer, micron. 0.22 micron. Okay na,
Point
so
two.
that comes in this range, microfiltration. Okay na. So generally, why we are using it, we are using to remove the dissolved and colloidal particles. So we want in our sample, we generally want everything which is in dissolved form. So what will happen that we will take our sample with the help of some syringe. We will put it here on this side, and we will apply the pressure. So what will happen, all the contaminated will get attached here, and we will have filtered water. So this is just a small example, but all the this miss, you won't be able to see the filter paper here, but you can see the, like this white paper is like white side is a filter paper of having micro of size 0.22 micron, that is 0.22 into 10 to the power minus 6 meter. This mu m is also known as micron. So when we are talking about microfiltration, then it is between zero point 0.1 to 10 micron. Micron या mu m pore size, okay na. And when the size is between 0.01 to 0. This which I have shown is ultrafiltration, and it has size less than zero point 0.1 micron. So it removes bacteria, suspended solids, and some protozoa. Do not remove viruses and dissolve contaminants. Okay, the thing which I have shown you. Then we have ultrafiltration, zero point 0.01 and zero point 0.1 micron. Removes bacteria, protozoa, and some larger viruses, but do not remove dissolve. Okay, because dissolves one are very dissolved salts are generally in the range of it is even lesser than zero point 0.1. Means there is a range, okay now, whatever is between is less than 0.22, and within the dissolve also we have some bifurcation, but I also don't know the what is the bifurcation of dissolve, but it is generally less than 0.22 micron. Examples used in drinking water treatment and wastewater reuse. Then we have nanofiltration. You can see it is even less. It is very less. We are in the range of nano, that is 10 to the power minus 9 meter. Remember, micron is 10 to the power minus 6, nano is 10 to the power minus 9. Bacteria, viruses, organic molecule, and some dissolve used for softening water. There can be many examples. Then we have reverse osmosis. Here, you this reverse osmosis is very common. That's why it is costly. Also, you can see the what is the pore size. It is very small. Okay, na. So bacteria, viruses, heavy metals, dissolve salts, and most organic. In our home also we are using reverse osmosis, because that is controlling our miss, that is removing all the dissolved salt also. Okay, now you can, so that's, did RO can remove all type of microorganism including yes, RO can remove all the microorganism including virus also. This is well proved. That's why it is widely used at every places. Wherever you go, which type of like what we call filter assembly you take. they are fully reliable on this reverse osmosis, because you can see the size, and virus's size is little bit bigger than this thing, so that all things are get entrapped here. Like that's why there is concept of, like, see how uh, you might have heard of this filter whatever is that, double RO, single RO, this type of thing. So what happened that the in reverse osmosis generally what happened that it will be, all the water will be passed here. Okay,
Okay.
then what will happen that there is surpass also, because this reverse osmosis is removing all the dissolved minerals, all the calcium, all the magnesium, but we know that we need some calcium and magnesium. Okay, so what will happen that to add the sufficient amount of water, so sufficient amount of calcium, there is a pH regulator. If you ever talk to salesperson, they will use this term TDS regulator. So that is not a in for them. It is TDS regulator, but simply we are just passing the water. Okay, na. So what happened that suppose here is zero amount of calcium is there, zero amount of sodium is there. Here X amount of calcium and Y amount of sodium will be coming there. There are chances that some of the viruses or some of the bacteria might also come here. So what happened that here we also add UV. So if somehow any bacteria is coming into the from what do we call surpass, then this will kill the bacteria and viruses. So in this way, your water will be filtered with the help of reverse osmosis. Bacteria will bacteria will be also removed, but there are chances that some of some viruses or bacteria may come here. So what will happen that for that we use UV. So this is very simple what do we diagram, but you can always go and check what is overall this, how reverse osmosis in our RO system works. But if the question to the answer, did RO can remove all type of microorganism including viruses? Yes, it can remove, and that's just because of size. The correct answer is D, all of these. I hope this is clear to you. Then we have question number 4. Which of the following mechanism is responsible for nanofiltration? I have B, that is 2 and 3. Let's see. Yes, correct answer is B, 2 and 3, size exclusion and charge based rejection. Nanofiltration is membrane filtration process that operates between ultrafiltration and reverse osmosis. It primarily removes divalent and largest monovalent ions, organic molecules, and microorganisms for water. The two main mechanisms responsible for nanofiltration are size exclusion. The nanofiltration membrane have poor size of range with this thing. This allows the small molecules and non-monovalent ion to pass through while rejecting the larger molecules like calcium, magnesium, bacteria, and organic. This is also called sieving or steric hindrance. So we are allowing for the smaller smaller ions to pass through the membrane, and we are retaining the uh, larger molecules like calcium and magnesium, and we know that bacteria and organic compounds have also larger size, so that will be also retained. And this is also known as sieving, okay, now, or steric hindrance. Nanofiltration are typically negatively charged, which repels anions. This electrostatic interaction enhances the rejection of divalent and multivalent ions, making nanofiltration effective for water softening and removal of contaminants like fluoride and sulfate. So, like there is these are some of the facts about nanofiltration. If you I'm not going to the main logic or science behind it, but these are the facts that someone should know if someone is working about nanofiltration. So it's like they are saying that yes, for fluoride removal, this nanofiltration works very well. But the problem is that it is very costly. Use of nanofiltration to treat fluoride is very costly. So that's why it is not used. You might not have heard that any place in normal village or any at any other location people are using nanofiltration to treat water. Only reason is there is no money. Nanofiltration does not rely purely on mechanical blocking like sands or microfilter. They involve molecular interaction at nano scale. So this thing from nanofiltration, like we are interacting at the nano levels. We don't need to apply any kind of pressure or any kind of force or all this thing. There is some requirement, but it is more towards we have focus on interaction in the nano levels. Solvent drag is phenomena in ultrafiltration which carry the solute along but not in. So I have shown you, if you like here, like here, this is ultrafiltration. Here we can see that what will happen, that what there will be like, what do I call, I sometimes I forget these technical terms, but I think you can understand it. That water flow carry this. So means there will be membrane. Water will carry it. The carry the what do I call, contaminants, and it will the contaminant will get trapped on the filtration units, and you will get the treated water. Correct answer is 2 and 3. Okay. Which of the following membrane is operated in a constant flux mode? Which of the following state when the membrane is operated at in a constant flux mode, which of the following statement are true? It is multiple correct. A. We have transmitted pressure will increase with time. Yes, correct answer is transmitted pressure will increase with the time. Flux is refers to this thing we have already known. So these thing I have copied from the lecture notes. Okay, now so I'm not going to discuss it here, but to understand what's happening here, I will just give you some small insight what is happening here. So, uh, sorry. In constant flux operation, the system maintains a fixed filtration rate, meaning the same amount of water passes through the member continuously. So we know that a area into, is anyone saying anything? Okay. Then we know that velocity multiplied by area into c is flux, and the unit is here liter meter square. Oh, what is the flux? J is ABC. 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 Huh. Meter A V C. Area into concentration. Just let me check. I just forget what is flux. If anyone remember what is flux, you can say. Huh. Water flux. Oh no, it is QYA. Okay, na. Flux is flow per unit area. So actually, see what I was saying, that different flux can be defined in different way. For example, I will show you another form of flux. Chapra. So in which reference we are using the flux? I'm sorry. I'm not going to discuss those things. But remember that in a simple way, flux here it is defined that through a particular membrane, a constant amount of water is going inside that full filter, and a constant amount of water is coming throughout. So that in order is constant flux, or simply whatever we are adding, same amount we are getting out for at equal interval. Like if we are adding x amount for x minute, by amount of water, then we are getting by amount of water in x amount of time. Or flow can be constant. That there are many way to interpret. The membrane transfer pressure is driving force that pushes the water through the membrane and influenced by resistance to from falling and membrane. So we have seen that there, due to some, there might be some interference due to particle attached or bacteria attached. So there will be resistance from these molecules. So what will happen that we are applying such pressure, and that pressure is known as transmembrane pressure. Okay na. So that is also including the pressure to resist this fouling to these to that is required to that is required here. Okay na. Why does TP increases over time? So if you like generally think like how we are applying pressure, so with time what will happen that divalent, some of the contaminant will start getting deposited on the time, on the sorry, on the membrane. So what will happen that with time we have to apply more pressure. This is simple logic, no science. It's common, like it's common, very common. Over time, particles, microorganisms, and dissolved substances accumulate on the membrane surface within its pores. This increases the resistance to the flow, requiring a higher pressure to maintain same flux. I hope this is clear to you. Some of other option is as water permeates rejected soluble accumulate near the membrane surface. This increases osmotic which in turns raises the required TP, required TMP. Okay, na irreversible falling effects even with cleaning. Some falling remains gradually increasing the TP over long terms. So these are some of the correct. These are some of the, like they were asking true. The only true is this. Here they are decreasing. No, it increases with time. Uh, Constant with time. No. Okay, na. These were some of the factors for TMP to increase. Okay. But simple thing, keep it in mind that with time there will be deposition of minerals or deposition of contaminants, and with time we have to apply more pressure if we want to keep the flux same. Remember why we want to, like our aim is to maintain the constant flux. That's why we have to increase the pressure. Correct answer is A. Transmittance power increases with time. Question number 6. During the reverse osmosis process, pressure is applied to the membrane is. This answer this question. This question is like, see, this question is very common question and many people गलत कर देता है इसको. Answer it. B. We got one answer, that is B. Greater than osmotic pressure. Let's see. The correct answer is greater than. Uh, hmm. So reverse osmosis is membrane-based separation and used for desalination and purification. The process rely applying external pressures to force water through a semi-permeable membrane, rejecting salts and other contaminants. Okay, na. So if you recall the osmosis, I think everyone is aware of what is osmosis pressure and what is osmosis and what is reverse osmosis. So see, osmosis, when we talk about it is movement of water. Okay, na. So generally, what will happen that uh, uh, this water will always move from what higher like water will mhm. Water will always move from where there is a high concentration. Okay, na. Sorry, water will move towards where there is a high concentration. Okay, like generally in if we talk about in soil and water, so this osmosis effect is seen. I have to, like but in reverse osmosis what is happening that uh, in reverse osmosis, what is happening, that we have a contaminated water, so here concentration is high and water is there, and here here we have a non-contaminated water, and we have this membrane. So in general, what should had happen, that as here it is high concentration, the water will should have to move from where there is low concentration toward this high concentration. But what is in reverse osmosis, what we are doing, that we are applying pressure at this side. I think this is common. I'm assuming that everyone know. That's why I'm not discussing. So to answer this question, you have to like greater than the osmotic pressure. Like, see, if there is osmotic pressure here, so what will happen, that water will start moving from this cleaner water will start to move towards the contaminated water. We don't want that. So what will happen, that we will apply a pressure greater than osmotic pressure, so that what will happen, that water will start moving towards in the downward direction. All the contaminants are getting trapped on here. Okay, so why must apply pressure that is greater, osmotic pressure or pi? Generally we represent by this, not see, generally pi is like this, but this is different. Remember, this is not like this is separate symbol. Pi is different thing. So, but generally, I don't know the term for this thing. Is pressure exerted by dissolved solids that naturally draw the water toward more concentrated side. What do I call that? If we have this thing, concentrated side, non-concentrated side. So, due to osmotic pressure, what will happen, that water will start moving here. In osmosis, water naturally moves from low solid concentration to a high concentration across semi-permeable water. See, low solid concentration. To reverse the natural flow, the applied pressure must be greater than the osmotic pressure, forcing the pure water to move from the saline side to pure side. This is like very interesting thing. People think like in osmosis, what happened, that see, when we talk about osmosis, we talk about the movement of water, not movement of contaminant. So you might have heard, if you apply the concept of pressure, why I am saying this thing is very important, because see, if you apply the concept of pressure, all water always moves, like there is concept na, that कि high pressure से low pressure लोग जाते हैं, like this is normal thing. But always think about that, जब हाई प्रेशर से लो प्रेशर जब होता है, जाता है कुछ, तो क्या जाता है, कंफ्यूज नहीं होना है, ठीक ना? तो सिंपली यहाँ पे भी ऑस्मोसिस में भी ये चीज होता है कि वाटर मूव करता है, क्योंकि देखो, अगर मतलब अगर सिंपल शब्द में बोले, तो क्या हो रहा है कि जो जहाँ पे फ्रेश वाटर है, वहाँ पे सॉल्यूट का कंसंट्रेशन कम है, लेकिन वाटर का तो कंसंट्रेशन ज़्यादा है। वाटर का कंसंट्रेशन तो फिक्सिंग होता है, लेकिन मतलब वाटर ज़्यादा अवेलेबल है, तो वाटर मूव करेगा कंटामिनेटेड साइड में, जहाँ पे सॉल्यूट का कंसंट्रेशन ज़्यादा है। इसलिए हम लोग अपोजिट में एक प्रेशर लगा रहे हैं, ताकि क्या हो, वाटर नीचे से आना नहीं शुरू करे, जो कि प्रेशर कितना अप्लाई करते हैं, ऑस्मोटिक प्रेशर से ज़्यादा। आई होप आई एम एबल टू एक्सप्लेन। अदर ऑप्शन ले, ये सब तो पोर प्लगिंग ऑफ मेम्ब्रेन हैपेंस ड्यू टू सी। The correct answer is particle of the same as that of pore size. Okay. Pore plugging or pore blocking in the membrane occurs when particles get trapped inside the membrane pores, reducing the permeability and reducing. So suppose we are using, suppose this is my filter, and I am always passing the water. It has a pore size of 0.22 micron. Now I am always passing the water having same. So what will happen? All the pores will get trapped, misfill, and this happens also, like like this is throw and use filters. Okay, now we filter it. So what will happen, that it will choke, and even how high pressure I will apply, it won't work. There might be like uh, पानी कभी कभी वापस आ जाता है, तो ये इसका, so this is another thing. So this is like, yes, correct answer is C. Why? Why does pore plugging happens with a particle of same size as the pore size? If the particle is larger than the pore, it will not enter the pore and instead accumulate on the membrane surface, leading to the cake formation rather than the pore plugging. But in this case also, what will happen that your filter will stop working. Efficiency will get efficiency will be reduced significantly because you have just blocked the path. If the particle is smaller, then obviously it will pass through. Then efficiency will be good. If the particle of same size, it can enter and get locked inside, leading to the pore plugging and significant loss of the filtration efficiency. Okay, so uh, this was the correct answer. That is C. Particle of the same size as that of the pore size. Then we have question number 9. I request everyone to please solve it. I'm coming in 1 minute. Those who are here, all I think 3 members. Let me check. I'm coming in 1 minute. I'm giving you 1 minute. Yes. Why it is not moving this side? Ah. 4 people are here. So I request everyone to please solve it. I'm coming in 1 minute. This question is directly from your notes. Use the formula or anything. There is no science behind it. C599. No, I don't think. Anyone, did anyone solve? This is related to this osmotic pressure. See, remember whenever this sign come, imagine osmotic pressure. Okay. Uh, Due to some work, I am not available tomorrow. That's why this was rescheduled for today. Those who have missed the initial part, the recording of this session will be uploaded on the YouTube channel. You can watch it. I think your mail is not working. Your mail is not working. What is saying? What be? My mail was this. Some of few. I think like I have already mailed them. This was my email ID. I hope you have written it down. mprakash23. But for regarding your oh, then I'm. But I have already mailed. Let me show you. I have already mailed them. I think they will take the action. See, I think this was your concern that for question number 8, the correct answer is this now. But some of you have marked point. Then I have asked them to consider the range of 28 to 20 between. If someone has marked between these two, so I think they will get the answer. Are you able to see my screen now? I think everyone is able to see my screen. For question number 10 also I have asked them to consider between 4.7 and to 4.8. So give them time. I will send it. I have sent it on Friday. Give them some time. I think they will consider it. I have sent. I have.
There, sir, can I ask some query? You?
Yeah, yeah, yeah.
From first assignment,
Sorry.
assignment assignment one from assignment one,
Huh.
number eight in the number eight in the number nine. The answer is correct, and also we have discussed with you in last session,
Hmm.
and you are promised to correct the answer, and it will be updated on the website. You have said it, but it's not yet corrected. And again from assignment 303, the answer matches or the answer is correct with your calculation, your work, but it's not correctly done. So
Okay.
can you check it from? I have also emailed to you, but your email is not actively working. Can you check it? Sorry.
Okay. No, I have not got any email. Just check this thing. Miss, like you were. See, this is my email ID. This thing here. It is my email ID. Just take a screenshot or anything. I have not got any mail from any one of you. If someone has mail anything, so this is my email ID.
Your last email is not working. It's not working. If it is the right email you give us,
Okay, I am
then
just
then
writing in
I
the chat box again.
okay again please write it. Okay, thank you.
And one more minute in question assignment. You are saying three. Someone is facing again some problem. Question number 4 and 5 are correct as per the solution sheet, but you have not given marks. Just 1 minute. Let me open the what do I call? Stop presenting. Let me open the assignment number 3. Just 1 minute. I am opening. Week 3. Okay, so week 3. What kind of problem are you facing? Question number 3. Question number 4. Question number 4. Question number 4. Oh, sorry. Here is 4. Correct answer is 1.3.
1.33 I have written in the box 1.38 method. Because of method you have I don't know for method or why I don't know. It's not right.
No, that they have asked the answer to like correct answer will be. Actually, I think there is some problem here. I think there should be always a range, not a particular answer. It will be between 3.1.3 to 1.4.
Yes,
So
sir, I have read 1.38 meter, but they answered me wrong.
okay, so
I have read
just 1 minute, 1 minute.
1.38
Let me note
meter.
down. Let me note down. I will write you. I will write a mail again. Question number 3. Oh, sorry, question number 4. The correct answer should be unit
And again, 5 also. 5 also.
5.
Okay, 1.3 to 1.4. I will ask them to regrade it. Okay, and
1.3
Question number 5. Number 5 also.
meters
see,
unit we have written.
see in when I think here, suppose when you are attempting this assignment, not submitted. Just try to don't write any word. Just answer. If it is numerical question, just answer in numerical form. Don't write 1.3 meter or 1.3, because they will consider meter as something, and they might not give you marks also. For example, if I am like big 4 is here.
But in the question, units are not given.
No, no,
So
in question.
you can see the question 4 number question.
Okay, just
If they given unit, we might have not written the units. It's just the height of the tower like that they had given. Can you please see that
ha 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 ha.
thing? Fourth question.
Okay, then I will mention it. Unit was
The
not
question
given.
meter is not written. That's why the answer we written the units.
Utilize 1.3 treatment. Okay, okay. For this, miss, there are high chances that what happened that as you have written him, but I will mail them. So let's see happen. So as said last time, also it will take some time for last for problems assignment. Also, one I request everyone to please wait for some time. By end of the date, everyone will get the deserving marks. No marks will be deducted. Don't worry about that.
Okay, for question number 5. Question number 5.
Question number 4. Question number 4. Uh,
Question number 5. Now we discussed the question number 4.
Question
Can
number.
you go to the question number 5? Here
Here the answer is A.
Uh,
as A, but in the question sheet they had marked as D.
when wastewater treatment grade
Five by
control apply the
A1.
following statement which describe the mechanism of. Age. But in which of the option they have correct considered as correct?
D,
A
sir.
is correct. A is correct. You haven't
In,
give mark for A.
in spite of marking A, you have not got marks.
The
Yes,
answer
sir.
is
We
A.
mark A. But they,
Okay. Question number 5.
There they marked the correct answer as D. We had marked A, they had put wrong answer like that.
Okay, okay, got it. Means in their portal they have marked B. Okay, got
D
it.
as the right answer there.
Primary no, that B is not correct. A is correct.
A is correct.
Okay, so question number 5 also A is correct. Okay, any more doubt?
Assignment 1, you will check, yeah? Or
Assignment
assignment
1,
1?
I have mailed them. You can see the proof issue with in assignment 1 grading. I have mailed to the this author. Yeah, what do I call? Responsible person. I think they will take some action. So just wait for some time, and if nothing happen, then remind me again on next week. I will just and for this assignment 3, I will mail it by today or maybe by tomorrow for sure. I think there was delay from my side. I mailed it on Friday. I should have mailed, but due to some work problem, I was not able to mail earlier. But I have mailed on Friday, and then Saturday Sunday was off. Then they must have seen this mail by today, so maybe they will be taking some action by today or tomorrow. So wait for some time.
Okay, we will email for you so that let us write the correct email on this chat box. Okay, thank you.
Okay. Any more doubts from previous assignment or any kind of problem?
Can we ask doubt in week 4 assignment?
Yeah.
In sixth question, can I ask doubt? Because now we
Yeah.
had discussed that RO membrane can remove all types of microorganisms or virus, but here that option is not there. No?
Week 4.
Yeah, sixth question I have doubt here.
Reverse osmosis uses which of the following is are true? Reverse osmosis uses semi-permeable membrane to remove the process require external pressure to overcome the natural osmotic pressure of the solution. Yeah. The reverse osmosis remove all type of viruses.
Here 1, 2, 3, 4, everything are correct now. Other than 5,
I think it will be 1, 2, 3, 4, but there is no such option.
yes.
The answer is 1 to 4.
Then I think I miss like for now this go for option B. Okay, na?
But
No, no.
it's also
No,
correct.
C, C.
Requires external
No,
pressure.
D. The answer is D.
Oh, option
D. Correct, it is D.
1 to 4.
Three indicated.
Yes.
Three is not correct. Three, reverse osmosis member can remove all types of microorganisms. It says all, not all.
Okay, for actually, see, reverse osmosis can remove all the type of microorganism and viruses. So, but for this question, I think I can mark option D. Like just 1 minute. Reverse definition of reverse osmosis. See here, you can see that this. If you see here, bacteria, protozoa, viruses, everything is being removed by. Uh, See, I will. If you have to mark the answer, then just for now, mark option D. Okay, na? Because I think they are not considering this as an answer. But as per theory, uh, if someone say that whether reverse osmosis can remove things or bacteria and microorganisms equilibrium or not, then I will be saying that yes, it can remove. But seeing this option, if I have to choose between, there is no 1, 2, 3, 4 option. So, but best suitable option here is D. So I will be going with D option. Okay, but I will check again. Okay, now, as far as I know, as far as I remember, I think reverse osmosis can remove all type of microorganisms and viruses. Okay, na. But in next lecture, I will confirm this. I have to check books. Yeah. Okay. So
Okay.
for now, just mark option D 1, 2, 4.
Okay, thank you. Thank you, sir.
Hmm. Okay. So coming to this question, I asked everyone to solve this. Did anyone solve it? This is directly from your lecture notes. Just try. See, directly from your lecture notes, I will be solving it. The estimate membrane. This is formula, direct formula. Okay, na. How this is derived? No need to know. Miss, there is need to know, but miss. Actually, I also don't know how this has come. But this is the formula that if here it is details about this formula. Where did it go? I, so this FW is flux. Okay, flux. Huh? Where? Huh? See, this q is flow is equal to this flux into area. Okay, na. And see this flow, if you remember, this flow has a unit of meter cube per second, but here we are talking about in the form of permeate stream flow rate. Like we are talking in the sense of what do I call, concentration. That's why unit here it is kg per second. But in if someone is talking about flow, I think I found it when I was going through the lecture, and I found it very like not a good way to write, but I cannot right now I cannot say. But generally, whenever we talk about q na, we talk in the sense of q is meter cube per second. That is general flow unit, meter cube per second, and generally the flux has similar unit in the meter cube something something something. But here, as they are talking about in the terms of permeate concentration, so that's why they have written as permeate stream flow as kg per second. Okay, na. So remember this thing, don't get confused. Like sometime you will be seeing, but always see the context, in which context they are discussing it. Okay, so this qp is fw into a, and there is formula to find fw is, and fw is found out by this formula, that is kw into pressure difference, delta pressure applied minus change osmotic pressure. Okay, so every detail has been given to you. If you look at here, what is the membrane TDS control? If the membrane has flux rate kW has been given to you, and the flow rate is itna meter cube, and the net operating pressure is minus delta P minus this much of pressure is applied. Okay na. So we know that Fw is Kw into delta P minus A. Fw we can multi by multiplying it we can find it. We will be getting Fw, and Qp is equal to Fw into A. Then we will be putting all these Fw into A. We will be putting all these value. Q have been already given. So remember, always here in the question, only thing which you might get confused with the playing with unit. So here it is kg per meter cube. Here it is per second. Here again it is meter cube per second, and so you have to convert your meter unit accordingly. That's what has been done here. Okay na. So uh, see, remember Fw unit is given in kg. Okay na. But if you see here, where it is. Hmm. See here we have multiply. See here again it is unit is given flow. Unit is given in meter cube per second. I hope you are getting what I am saying. I will agree that if you go through the lectures and notes, there will be little bit confusing. But if you have watched the video and like truly gone through this unit conversion, you will be getting it. Again here, see here they have unit given unit as meter cube per second. But you know that for the formula we require unit in kg per second. So you have to convert this meter cube into meter cube. So
By multiplying with density, we
by
can.
multiplying it with density, see here they have multiplied by density, that is 10 to the power 3 kg per second. So don't get confused. But in general, again I'm saying it, but in general, if someone asks what is the unit of flow, then you will always report it as meter cube per second, not kg per second. Kg per second is not a unit of flow.
It's a mass rate.
That is mass rate, that is a different thing. So here you can we have find A is equal to 1.666 meter cube or 1667 meter cube. Again when I will be report it is not a numerical question, but sorry, that's all. Again here again a very simple question. Calculate the salt density index. That is this salt density index has a direct formula.
Density.
The formula is here written.
SD equal to 100
Here
minus.
it is formula is here. STI is equal to 100 1 minus TI divided by TF divided by D. Everything has been given to you. 1 minus TI minus TF divided by T. T is the initial time to collect 500 ml. TF is the final time to collect 500 ml. D is time duration, usually 15 minutes for HD15, but here it is 16 minutes. Okay now. The initial time written, you can see in the question, it is 4 minutes. It is 4 minutes, and final at 20 minutes. Then we have 20 plus 4 minutes, and as total was 30, total test duration was 30 minutes. So the t will be 24 plus minus 4, that is 16 minutes. Like you can see that 20 minutes was time to collect, 4 minutes was time to for initial collection, and so in between there is a test duration of 16 minutes. I will be putting all these value and getting STI as 2.67. I hope this is clear to you. Any doubt on this thing? This is simple question. I think there should be no doubt. I think someone's mic is on. I don't know whose mic is on. Oh. Hmm. Coming to the I don't think I have lots of question today, but I don't think I will be able to cover it. But again, this is numerical question, again directly from your what do I call, PDF. I think desalination of brackish water with a total dissolved TDS of 3 kg per meter cube. So you can see in 1 meter cube 3 kg of salt is there. Very high TDS. Is planned to using a thin film composite membrane. The membrane feature has a flux rate coefficient Kw as this much, 10 to the power minus 6 per second, and mass transfer Ki is 1.8 into 10 to the power minus 6 meter per second. The specified flow rate is itna meter cube per second. Again, see here, see this unit is given in zero point zero meter per second. If that formula is required, then we'll be multiplying it with density, but let's see whether that is required or not. Again, operating pressure is this much. Assume the recovery rate is itna percent. The anticipated area is also given. The estimate the permeate TDS concentration, like the uh, TDS, permeate TDS means like you have to find the whatever what do I call permeate, the TDS concentration in the permeate. Initially this was how is the like final TDS, you can also say. So again, this is from your book also on what do I call, here you can see we use this formula. Okay na. Actually it is directly, I'm just going through different terms used in this formula. I was like all the different terms used in this formula is given here. Okay now I'm going, I'm here. See, this is this thing which I have already said that water flux rate is Kw into pressure, average pressure imposed minus osmotic pressure is equal to Qp by A. Qp is C. Actually, this formula is itself in kg per second. That's why we have converted meter cube per second into kg. Okay. Solid flux is a function of constant gradation. Then we will be using huh. So this was all about this thing, and here you can see that this is my final solution. This Fi is equal to Ki into delta C, that is Qp into Cp by A. Ci means initial concentration they are talking, initial means like permeate concentration they are talking about.
C is concentration gradient.
Ha. So again, in the question itself, they have written that we have to assume the this permeate concentration. What is Cc and Cf? You can see here. Here it is written Cc. Cc solid concentration in solid concentration is concentrated stream, and Cf is the solid concentration in the feed system stream. And generally, and we have also Cp, and we have to find this Cp, that is solid concentration in permeate concentration. So we will be putting all the value here. You can see that Cp is equal to Ki into A into Cf divided by Qp plus Ki into A. So see, this formula is has means like it has been come with the help of mass balance. Okay, now what is this mass balance? Like there is formula, like not formula, like how much mass is coming, how much mass is going, plus minus there will be some reaction term due to which concentration will be either increasing or decreasing. With the help of that, this thing has been defined. Okay now. So like if you have to know more about this formula, last lecture also I have suggested one book, that is Chhapra. This time also, like if someone has missed about this book, go and read this book. They have talked about this mass balance in a very good way. It's like in very detailed manner how different it's like for a system, if something is coming and something is going and some reaction is happening, then how different equation is derived. Here you can see it. But for now, I will be just saying that everything has been given to you. We have put the value and we have found out the, it was direct means every value was given to you. You have to substitute the values in the formula. Any doubt in this thing? Ki was given to you, area was given to you, QP was given to you. Efficiency, you can see the efficiency was 85%. The recovery rate is 85%. That's why we have multiplied it by 0.85. Plus Ki was given to you and area was also given to you. We have put all the value and we have found out this thing. I hope this is clear to you. Before discussing like objective question, I will go to numerical question. Numerical questions are more not challenging, but the theory questions are very simple. Not simple, huh? Take 1 or 2 minutes and try to solve it. This is again from your what do I call PDF. Recovery rate percentage if the permeate flow is 96 meter cube per day. Rate of rejection percentage of suspended solid. Is anyone trying it or should I show the solution? Please, we have very less time. Only 20 minutes are left. I have to cover some questions like you can see I have directly jumped from 10 to 21. I will directly go to the solution. So, see, there is filtration membrane to treat this much of water per day, itna meter cube of water. The initial concentration is 50 milligram per, and the permeate has a concentration of 5 milligram per liter. Okay, na. So the formula is very like if you recall the okay. Uh, the recovery percentage is given by this simple formula, that is QP divided by QF into 100, where QF is feed flow, means how much water is coming. Q QF is feed flow, by that how much water is feed matlab means in system we are providing some water, we are feeding, that is feed flow. Then permeate flow, that is coming out of the system. Okay, na. The formula is very simple, we will put, then R is 80%. Okay, then we have rate of rejection rate. See, Miss, like I'm telling you with my experience from last 1 year. So if your PDF contain 5 numerical question, 2 or 3 question will be asked in your assignment, and 2 question will be asked in your final examination. Okay, na. But it's for sure that all the numerical which is there will be asked to you once, and you will be seeing that only like values are changed there in your PDF. It will be 80%, in your final examination it will be 85%. Sometimes those value will won't be changed. So I will request that and you will see that there sometimes there are high chances that numerical questions have higher marks given to them. Okay, now. So miss it's my advice to you, just solve all the numerical question that is in your PDF or lecture notes. because you will get numerical questions are very straightforward. You have to mug up some formulas, and if you understood those formula, you can just note it down, keep it in your mind. You can add the value and you can find it. You can see this rate of recovery was simple qp by qf. Then we have rate of rejection, that is also cf minus cp divided by cf. Again, what I have said, cf means cf is feed concentration, cp is permeate concentration. Final answer is 90%. Good that someone has answered it 90%. Again, one easy one again very simple question, take 1 minute of time. I won't be giving more than 1 minute. A reverse osmosis is used to treat this much of water. The feed water has a total density of ethanol. The system operates at recovery rate of 85. See, this question is reverse of what I have discussed. You have to find permeate, then TDS concentration, and then the concentration in the constant, that is CC. So this is just testing of what you have done previously, whether you were able to listen carefully or not. There are simple two formula based on these two simple, and these questions is also in your what do I call lecture notes. You can see um, what I'm doing here is kind of recapping things. I'm not sharing any new things. Okay, now I think everyone got a feedback form, na, like feedback about don't like. I don't know how you are giving me feedback to me. I hope I am able to solve your problem or want to anything. You're like, if you are spending 2 hours here and your motives are clear, like you are benefiting it from here. I hope I am able to help you all. Hmm. So this was very simple. We know the formula R percentage is QP by QF into 100. You have already see feed is given to you, that is 85%, sorry, 150 meter cube per second. Then you have to find R means like this much of water is coming, going this much of is going, but this permeate concentration is only this much. Okay, because we have a recovery rate of only 85%. Then second question was about permeate concentration, just similar to that other question. In that question, you have to find R percentage, but here R percentage was given to you, and you have to find CP. Okay, permeate concentration. So again, we will be putting this value, and you will be final answer is 25 milligram per liter. And the final question is using mass balance. Okay, na, TDS concentrate into acha, miss, I was about to ask one question, like you are giving this much here in this question also, uh, this much water is going in, but water coming out is only 96 meter cube per second. So what is happening to extra 24? Here also in this question you can see that we are giving 150 meter cube per and coming out in permeate is 127.5. So what is happening to the extra? So we know that when we treat it, there are two part. One is like uh, there will be permeate and there will be concentrate. Okay, na, so our flow is bifurcating in two part. Okay, na, so that is happening here. So initially whatever, so if you recall our previous lecture, then there we have solved one question, that a river is flowing with C1 concentration and Q1 flow, and here we have added one from one industry something is coming with Q, suppose it is flowing with Q1 and it is flowing with Q2. Okay, here it is C1, here it is C2. Okay, so what will happen, that finally here it will be q into the final concentration is q and c. So we know that q as nothing is getting anywhere else, so the q will be q1 plus q2. Okay, q1 plus q2. Okay, and what will happen that this there will be mass balance, that whatever is coming is going out. So q1 into c1 is equal to q1 into c1 is mass in, sorry, q1 into c1 is mass out. So and what is coming it q1, sorry, q into not q, why I have written q1 here. Hmm. Here, like I'm saying that coming from our system, we have at inlet the system which is the concentration which is going has a flow of q into c, and q we have know that it is equal to q1 plus c, q1 plus q2, and total mass balance is like in mass balance saying that whatever the mass is coming, same amount of mass is going out. So what, how much mass is coming q1 into c1 plus q2 into c2. So here you can say imagine that p is 1 and c is 2. So you can see that q1 into c1 plus q2 into c2 is equal to q into c, and you have already know that q is equal to q1 plus q2, so here you will put the value. This is simple mass balance for this, like here like there is no reaction and all these things. So generally what happen that some kind of reaction is also happening, we have to add those terms also. For that type of question you can refer the book, chapter book. Here we have put the value, we have substituting the value, finally CC is 3191.64 milligram per liter. I hope this is clear to you. So you can from here you can also say that like you can just imagine that this much TDS was coming, milligram per liter was coming, out of which this much concentration was going in the permeate, and this much concentration was going in the concentrate. Any doubt in this thing? I have some. I hope. See anyone any doubt? Not thank you now. Just go to miss be fast, like just these are some of the more questions. What is the optimal pH range, anyone? जल्दी जल्दी आंसर करो, 10 मिनट टाइम है हमारे पास अभी. Which is the optimal pH range for OAP? This thing I have covered. If you are at those who have joined initially, I have said this thing. TNPCB. Tamil Nadu. D. No, you are wrong. Like the correct optimal pH range is 3 to 5, because what happened that this thing I don't know why you said. See here we are talking about like hmm. This thing has been discussed in your lecture also. You can see that most uh, the optimal pH range is like between 3 and 5. Just go to the video lecture, you will like understand it. Don't get confused. I know why you are saying 9 and 5. I got it. Here the question is was different. Here question is different. Where does that question? I hope miss I am just assuming it. Uh, Here they are talking about another thing, transfer efficiency and all this thing. Okay na, transfer efficiency is another thing, that is like how ozone is getting entrapped and all this thing. But here we are talking about another thing. Here we are talking about what we are talking about. Ah, we are talking about for with the help of UV, at which pH this OH radical production will be highest, and that is between 3 and 5. I have given some reason. This PDF will be, this PPT will be shared with you. You can watch it anytime. I hope you have understood. Miss, just hydroxygenation immersion acidic metal at very low pH, the radical formation in at high pH hydroxide react with OH minus, reducing its ability. Hence, pH itna is optimal for AOP efficiency. How do carbonates affects UV based AOP? Question number 12 it is, but I don't know why to. Hmm. Anyone? This thing I have also discussed. This is because it reacts with, they react with OH and reduce oxidation efficiency. That's why. Simple. There is reaction is also written in your book lecture notes. You can see that OH radicals is interacting with carbonates because, and you can see that overall efficiency, because this is not so reactive. Okay na, and this is not also overall efficiency get decreased, is reduced. So option B is correct. Question number 13. What is the primary reason for mass transfer limitation in UV slash ozone based AOP, that is ozone based radicals? What is the primary reason of mass transfer limitation? This thing has been discussed to you. Answer is ozone has low solubility in water. In ozone based OAP, ozone needs to dissolve in water before reacting with hydroxyl. However, ozone has low solubility and is not properly transfer into the water. The process become inefficient. This is the key mass transfer limitation in ozone based AOP. I hope this is clear to you. Question number: which factor can cause UV light to wasted in AOP system? The answer is C. High turbidity and presence of dissolved organic matter. UV light can be absorbed or scattered by suspended particle, dissolved organic matter, and other substances. Therefore, it reaches before it reaches contaminants. This reduces the effectiveness of UV disinfectants and radical generation, leading to light wasting. I hope this is clear to you. Due to presence of organic matter or suspended particle, there will be loss. Then we have question number 15. Why the medium pressure mercury lamps preferred over low pressure lamps for UV disinfection in large scale application? The correct answer is B. They have higher germicidal intensity. The medium pressure mercury lamp emits UV radiation with itna time uh, higher germicidal intensity compared to the low pressure lamps. Like it's like obviously the lower pressure lamp will kill more germs and all these things. Medium size will kill more, and so this allow faster disinfection and deeper penetration, making them more suitable for large scale application. However, they consume more energy and operate at higher temperature. Which of the following member has the smallest pore size? I have discussed it. Reverse osmosis. Microfiltration lie between 0.1 to 10 micron. Ultrafiltration lie between 0.01 to 0.1 micron. Nanofiltration, this thing, and the smallest pore is reverse osmosis. You should know reverse osmosis concept, its concept, how this thing and all this thing. What is the primary driving force in reverse osmosis? I have discussed about reverse osmosis, many details about reverse osmosis. I think everyone should be able to answer this. What is the primary driving force in reverse osmosis? D won't be the answer. That is for sure. Then temperature gradient, it does not play any role. Out of B and C, concentration difference or applied pressure? C. Yes, correct answer is C. Because C, B, we know that whatever there be concentration, it doesn't matter. If there is a pressure, like there is osmotic pressure, we have to apply pressure more than that. That's all. This is the primary concept. Reverse osmosis by applying pressure greater than the osmotic pressure on the feed solution, forcing water molecules through the same semi-permeable membrane while leaving the dissolved salts and impurities behind. This makes pressure the main driving force in RO. What is the primary cause of membrane fouling in wastewater? Again, very easy question. The answer is B. Presence of suspended solids, microorganisms, scaling. All these will get um, trapped on the membrane surface, making it falling condition or efficiency will get decreased. Okay, now which membrane configuration consists? This is related to like a structure of membrane. From name you can say which of the consist flat sheets bound in a spiral around a permeable tube. The answer is D. Yes, as it is saying a spiral around, and there is only one option of a spiral bond. Okay, now high surface area in a small volume, efficient, low falling compared to the hollow fiber member. These details are available in your PDF, the lecture notes. Last question: what is the purpose of HDI in membrane filtration? Remember the formula. From formula, try to like when we calculate HDI, that is silt density index. What we are trying to find? To measure the membrane permeability, to determine the falling potential, to test the salt rejection efficiency, to analyze dissolved oxygen in water. Anyone? Anyone? Last question. Last question of the day. Answer it and go home. Anyone? Belete Basa. BB, then we have TM. I don't know how to pronounce your name. That's why I'm not able to read your name. Metours. D. We have one answer D. To no. First of all, there is no role of dissolved oxygen in membrane. Throughout the membrane, you will never see at any place they are talking about dissolved oxygen. I don't know why did you say dissolved oxygen. The correct answer is to determine the falling potential of the feed water. HDI is test that measure the rate at which particular clog a membrane filter, that is of its size, under constant pressure. A higher steady HDI value indicates a greater tendency for falling, requiring pre-treatment. RO typically has HDI less than 3 for optical. Like see, HDI just represent like how fast you have to retreat or rewash or backwash this thing. Means how frequently your filter membrane will get clogged. Okay, that was all for today. Anyone have any doubt? Anyone have any doubt? I have noted down your problems about assignment 3, and I will sure mail them, and I will just send a gentle reminder for assignment 1 also, so that they can have a look and they can correct, they can give you marks, proper marks. Apart from that, anyone have any kind of doubt? If no, then I think we can what I can end the meeting here. Where did it go? Okay, so I think no one has no doubt. Thank you for everyone for attending the session. From next Tuesday, it will be normal. That is, from next Tuesday, we will be meeting at our normal time. That is between 6 p.m. to 8 p.m. Okay, na. So that's all for today. Tata. I'm ending the meeting. Thank you everyone for joining.